So, welcome to this video. Thank you so much for tuning in and hope you will learn something new today. Yes, so let's get right started with the topic of this video. I think everybody already heard of the planet 9 or planet X that should be in our solar system, but in the outer of the solar system, so way farther away than Pluto is. I know Pluto is not a planet, but it's just way farther than Pluto, maybe even light years, many light years away. We don't know because we don't know if this planet is actually there or not. But this month, Hubble discovered a strange exoplanet that resembles the long sought Planet 9. The 11th Jupiter mass exoplanet called HD 106906b occupies an unlikely orbit around a double star 336 light years away, and it may be offering clues to something that might be much closer to home. A hypothesized distant member of our solar system, dubbed Planet 9. This is the first time that astronomers have been able to measure the motion of a massive Jupiter-like planet that is orbiting very far from its host star and visible debris disk. The exoplanet HD 10690 with the Magellan telescopes at the Los Campos Observatory in Chile's Atacama Desert. However, astronomers did not know anything about the planet's orbit. This required something only the Hubble telescope could do: collect very accurate measurements of the weak bond's motion over 14 years with extraordinary precision. The exoplanet resides extremely far from its host pair of bright young stars, more than 730 times the distance of Earth from the Sun. This wide separation made it enormously challenging to determine the 15,000-year-long orbit in such a short time span of Hubble observations. The planet is creeping very slowly along its orbit, given the weak gravitational pull of its very distant parent stars. The Hubble team behind the new result was surprised to find that the remote world has an extreme orbit that is very inclined, elongated, and external to a dusty debris disk that surrounds the exoplanet's twin host stars. The debris disk itself is very extraordinary, perhaps due to the gravitational tug of the rogue planet. I hope everybody knows what's a rogue planet. A rogue planet, if you don't know, is a planet that is not like linked to a star. It's just flying alone through the to the galaxy or through the universe. Yes. This study was led by Meiji Nugent, hope I pronounced her name right, of the University of California, Berkeley. To highlight why this is weird, we can just look at our own solar system and see that all of the planets lie roughly in the same plane. Explained Nujuin. It would be bizarre if, say, Jupiter just happened to be inclined 30 degrees relative to the plane that every other planet orbits in. This raises all sorts of questions about how HD 106906b ended up so far out on such an inclined orbit. The prevailing theory to explain how the exoplanet arrived at such a distant and strangely inclined orbit is that it formed much closer to its stars, about 3 times the distance that Earth is from the Sun. However, drag within the system's gas disk caused by the planet's orbit to decay, forcing it to migrate inward toward its stellar host. The gravitational forces from the whirling twin stars then kicked it out onto an eccentric orbit that almost threw it out of the system and into the void of interstellar space. Then the star passed very close by to its system, stabilizing the exoplanet's orbit and preventing it from leaving its home system. Candidate passing stars have been previously identified using precise distance and motion measurements from the European Space Agency's Gaia survey satellite. This scenario to explain HG 106906b's bizarre orbit is similar in some ways to what may have caused the hypothetical planet 9 to end up in the outer reaches of our own solar system beyond the Kuiper belt. Kuiper belt, Planet 9 could have formed in the inner solar system and then was kicked out by interactions with Jupiter. However, Jupiter would very likely have flung Planet 9 far beyond Pluto. 6b was discovered in 2013. Pluto. Passing stars may have stabilized the orbit of the kicked out planet by pushing the orbit path away from Jupiter and the other planets in the inner solar system. It's as if we have a time machine for our own solar system going back 4.6 billion years to see what may have happened when our young solar system was dynamically active and everything was being jostled around and rearranged, explained team member Paul Callas of the University of California, Berkeley. To date, astronomers have only circumstantial evidence for the existence of Planet 9. They found a cluster of small celestial bodies beyond Neptune that move in unusual orbits compared to the rest of the solar system. This configuration, some astronomers think, suggests that these objects were shepherded together by a gravitational pull of a huge unseen planet. An alternative hypothesis is that there is not one giant perturber, but instead the imbalance is due to the combined gravitational influence of much smaller objects. Despite the lack of detection of Planet 9 to date, the orbit of the planet can be inferred based on its effect of the various objects in the outer solar system, explained team member Robert De Rosa of the European Southern Observatory in Santiago, Chile, who led the study's analysis. This suggests that if a planet was indeed responsible for what we observe in the orbits of trans-Neptunian objects, it should have an eccentric orbit inclined relative to the plane of the solar system. This prediction of the orbit of Planet 9 is similar to what we are seeing with HD 106906b. Scientists using the upcoming NASA ESA CSA James Webb Telescope, which will be launched into the orbit next year, which I'm really excited for, plan to get additional data on HD 106906b to better understand the planet system. Astronomers want to know where and how the planet formed and whether the plane has its own debris system around it, among other questions. There are still a lot of open questions about this system, added De Rosa. For example, we do not conclusively know where or how the planet formed. Although we have made the first measurements of orbital motion, there are still large uncertainties on the various orbital parameters. It is likely that both observers and theorists alike will be studying HD 106906b for years to come, unraveling the many mysteries of this remarkable planetary system. So yeah, and there's one thing I want to add to that. Many people maybe ask themselves, why is it so hard to find this planet? Because like we find galaxies that are billion of light years away, but not this one particular planet. So basically, a galaxy as an example, the lights are like brightening it up, but the planet 9 or X is so far from the sun or from its own sun. We don't know if it's orbiting around our sun or around another, but it's so far away that the sun gives actually like no light, so it's basically dark and we can not or barely see it. So next year we will have some more information with the James Webb Telescope to come. As soon as we have these informations, I will keep you guys up to date, of course. Then I will make a video about that. But what do you guys think about Planet 9 or X? Write it down in the comment section below the video, and thank you so much for listening in this video. We will see us in the next video again, and goodbye. Have a great time.